Hello friends, thanks for joining me. Today I'll talk about multiplication of fractions. First, let's review the basics of multiplication. Multiplication is a faster way to take the same number multiple times and add them up. In a multiplication expression, each number has a specific role. One is called the multiplicand, and the other is called the multiplier. The multiplicand is the number we take and add up, and the multiplier tells us how many times we do that. When people see the expression displayed on the screen, they often say 30 times 2 in everyday English, without thinking much about which number is the multiplicand and which is the multiplier. But in this video, we will clearly define the roles and read multiplication expressions accordingly. Technically, in 30 times 2, 30 is the multiplier and 2 is the multiplicand. So we literally take 2 30 times and add it up. However, in this video, we will use 30 multiplied by 2, where 30 is the multiplicand and 2 is the multiplier. So when we say 30 multiplied by 2, we take 30 2 times and add it up. In other words, 30 multiplied by 2 equals 30 plus 30 equals 60. But what if the multiplier is not a whole number but a fraction, such as 2/3? If we view multiplication as a faster way to take the multiplicand multiple times and add it up, then multiplying 30 by 2/3 would mean taking 30 only 2/3 times and adding up those parts. However, it's not easy to understand what it means to take something only 2/3 times and add it up instead of taking it multiple times. To understand this better, let's approach multiplication in a different way. For example, imagine you have a job where your hourly wage is $30. If you work for 2 hours, what are your total wages? We can find the answer by using a simple formula. Hourly wage multiplied by hours worked equals total wages. Since your hourly wage is $30 and you work for 2 hours, this formula becomes 30 multiplied by 2 equals 60. So your total wages are $60. You worked for 2 full hours, so you received a full payment of $30 for each 1 hour, twice in total. So far, this is just simple multiplication. Now, what if you only work for 2/3 hour? We can use the same formula in this case as well. Hourly wage multiplied by hours worked equals total wages. Since your hourly wage is $30 and you work for 2/3 hour, the left side of this formula becomes 30 multiplied by 2/3. But how do we calculate 30 multiplied by 2/3? Let's think about it the same way we did with the 2-hour case. Earlier, you worked for 2 full hours, so you received 2 full amounts of your hourly wage of $30. But this time you work only for 2 out of 3 equal parts of 1 hour. So instead of receiving the full $30, you will receive only a part of it, based on the amount of time worked. 2/3 hour means that 1 hour is divided into 3 equal parts, and then 2 of them are added up. In the same way, the wages you receive for 2/3 hour of work mean that your full hourly wage of $30 is divided into 3 equal parts, and then 2 of them are added up. If we write this directly as an expression to find your total wages, it becomes 30 divided by 3 multiplied by 2, and when we calculate it, we get 10 multiplied by 2 equals 20. So your total wages are $20. Since we set up the expression 30 multiplied by 2/3 to find your total wages, which we've just found, we can see that 30 multiplied by 2/3 is equivalent to 30 divided by 3 multiplied by 2. In the expression 30 divided by 3 multiplied by 2, the divisor 3 and the multiplier 2 come from the denominator and numerator of the 2/3 in the expression 30 multiplied by 2/3, respectively. Expressing time in hours as a fraction, such as 2/3, means dividing 1 hour into as many equal parts as the denominator indicates, and adding up as many of those parts as the numerator indicates. Since wages are earned based on the amount of time worked, your hourly wage, that is the wage per 1 hour, is also divided into as many equal parts as the denominator indicates, and as many of those parts as the numerator indicates are added up. Unlike the case of multiplying by a whole number, where we simply take the multiplicand multiple times and add it up, when multiplying by a fraction, we first divide the multiplicand into as many equal parts as the denominator indicates, and then take one of those parts as many times as the numerator indicates and add them up. In short, instead of multiplying by a fraction directly, you can first divide by the denominator and then multiply by the numerator. Just as a side note, this way of thinking not only means that we can rewrite multiplying by a single fraction as dividing and then multiplying by whole numbers to break the expression down into more basic components, but also that we can reverse it and rewrite dividing and then multiplying by whole numbers as multiplying by a single fraction to simplify the expression. In this video, we call this two-way connection the equivalence rule of multiplying by a fraction, so try to remember this name. Next, let's think about how to multiply when both the multiplicand and the multiplier are fractions, such as 2/3 multiplied by 4/5. We'll explore a way to calculate this more advanced expression through another real-life example. Imagine you have a lunch break that lasts 2/3 hour. Let's say you divide this 2/3 hour lunch break into 5 equal parts and use 4 out of those parts for eating. Now, what fraction of an hour do you actually spend eating? To find this fraction, we first divide the lunch break into 5 equal parts. This can be written directly as the expression 2/3 divided by 5. Then we add up 4 of these parts. This can be written directly as the expression 2/3 divided by 5 multiplied by 4. Earlier, we explained the equivalence rule of multiplying by a fraction, which says that dividing by a whole number and then multiplying by another whole number can be rewritten as multiplying by a single fraction. By using this rule, we can see that 2/3 divided by 5 multiplied by 4 is equivalent to 2/3 multiplied by 4/5, which results in the equation 2/3 multiplied by 4/5 equals 2/3 divided by 5 multiplied by 4. Here, a new fraction 4/5 appears as the multiplier, But it's important to notice that it appears in a different way from the fraction as a multiplier in the earlier wage example. In the wage example, we directly use the formula hourly wage multiplied by hours worked equals total wages. And by putting 2/3 as a specific time value in hours into it, the multiplier 2/3 appears right at the beginning. However, since it seemed difficult to calculate this directly, we used a diagram to think through the situation and arrived at the expression 30 divided by 3 multiplied by 2. Through this thinking process, we discovered the equivalence rule. Multiplying by a single fraction is equivalent to dividing by the denominator and then multiplying by the numerator. Unlike the wage example, in this lunch break example, we first set up the expression 2/3 divided by 5 multiplied by 4 to reflect the situation. And by using the equivalence rule we discovered in the wage example, we connected the expression 2/3 divided by 5 multiplied by 4 to the multiplication of fractions as 2/3 multiplied by 4/5. Now then, as for this expression 2/3 divided by 5 multiplied by 4, we would normally try to divide 2/3 by 5 first, following the same kind of thinking we used in the wage example. However, unlike in the wage example, since the dividend 2/3 itself is already less than 1, dividing 2/3 by 5 gives a number far less than 1 and clearly not a whole number. So dividing 2/3 directly does not seem easy. So instead of dividing directly, let's try using a diagram to help us calculate the expression in this problem more clearly. First, we start by drawing a rectangle that shows 1 hour as an area because we want to find a fraction of 1 hour. Next, we show the 2/3 hour lunch break. To do this, we divide the 1 hour rectangle into 3 equal vertical parts by drawing 2 horizontal lines and color 2 of them green. Now we divide each of the 2 green rectangles into 5 equal horizontal parts by drawing 4 vertical lines in each one. Out of these 5 parts in each rectangle, we take 4 of them to show the time spent eating and color them red. Let's find out 2 things: how many equal parts the 1 hour rectangle is divided into, and how many of those parts make up the red area. To do this, we extend the 4 vertical lines drawn in the lunch break area across the entire 1 hour rectangle. Now, how many equal parts is the entire 1 hour rectangle divided into? Since it is divided into 3 vertical parts and 5 horizontal parts, we can see that it is divided into 3 multiplied by 5 equals 15 equal parts. Next, how many of these small rectangles are red and show the time spent eating? There are 2 small rectangles vertically and 4 small rectangles horizontally, so 2 multiplied by 4 equals 8 small red rectangles show the time spent eating. In other words, the time spent eating is shown by 8 out of the 15 equal parts that make up the entire 1 hour rectangle. So the time spent eating is 8/15 of 1 hour, that is 8/15 hour, as calculated by 2 multiplied by 4 over 3 multiplied by 5 equals 8/15. Up until now, we've used a diagram to think about the expression 2/3 divided by 5 multiplied by 4. However, we now know that by using the equivalence rule, we can rewrite this expression as 2/3 multiplied by 4/5. And by combining this rewrite with our diagram-based thinking, we can see that 2/3 multiplied by 4/5 equals 2 multiplied by 4 over 3 multiplied by 5 equals 8/15. So the calculation technique for multiplying fractions is simple. Multiply the numerators together and then the denominators together. This technique works for any pair of fractions we multiply. This is because, in the lunch break example, the total number of small rectangles forming the new denominator is the product of the two denominators, and the total number of small red rectangles forming the new numerator is the product of the two numerators. By the way, by rewriting dividing by a whole number and then multiplying by another whole number as multiplying by a fraction, we can use the calculation technique for multiplying fractions and avoid the need for direct division, which might make the calculation complicated. Moreover, our calculation technique for multiplying fractions allows us to multiply a fraction by a whole number. Here we can think of the whole number as a fraction with a denominator of 1 and a numerator equal to the whole number itself. This way, the multiplication becomes a case of fraction multiplied by fraction, so we can use our calculation technique for multiplying fractions. We multiply the numerators together and then the denominators together. In this calculation, since we multiply by 1 in the denominator, which has no effect, we can keep the denominator the same and just multiply the numerator by the whole number. Next, let's also look at how to divide a fraction by a whole number. If we think of dividing a fraction by a whole number as dividing by a whole number and then multiplying by 1, we can use the rule we learned earlier, the equivalence rule of multiplying by a fraction. Dividing by a whole number and then multiplying by another whole number can be rewritten as multiplying by a single fraction where the numerator is the multiplier and the denominator is the divisor. Since the multiplier here is 1, dividing by a whole number is the same as multiplying by a fraction, where the numerator is 1 and the denominator is the same whole number. This way, without dividing directly, we can simply think of it as multiplying by a fraction. This means we can use our calculation technique for multiplying fractions. We multiply the numerators together and then the denominators together. In this calculation, since we multiply by 1 in the numerator, which has no effect, we can keep the numerator the same and just multiply the denominator by the whole number. So then how should we calculate when dividing by a fraction? I'll talk about that in another video. That's it for this video. Thanks for watching. If you found it helpful, don't forget to like and subscribe.